Okay, now we talked last time about some things that were true for all parallelograms, but I'm going to tweak this parallelogram a little bit and kind of give it some right angles in the corner, and it's going to be now a rectangle. So because this parallelogram is a rectangle, there's some new things that are equal, and there's really not a lot new being added as far as what adds together with this rectangle. So we'll just make a list of a few more things that are equal if I have a rectangle here. So additional things that are equal if this rectangle is a parallelogram is a rectangle. Once again, let's label it A, B, C, D so we can talk about it. Now it's true that all of the angles are equal. So all four angles are equal to each other now. It's still true that if I add A plus B, the adjacent ones together, they equal 180. But all of the angles are equal, and since they all equal to each other, the total is 360. So 360 divided by 4 means that not all of the angles are equal to each other, but they also equal 90 degrees because I have to divide this 360 up equally among all my angles. Another thing that is true for a rectangle is it is true that the diagonals now are equal. So that means the whole thing AC has to be equal to the whole length BD. And what that means is if I call that point in the middle E, since my entire diagonals are equal and AC is cut in half, let me show you in red here, with AE and EC are both equal. And if it's also true that EB and ED are equal, since the whole pieces are equal, and each of the pieces divided into two equal pieces, it's kind of like you have two medium pizzas. If you cut them both in half, all four halves are equal. So it's also true that any of those four subsegments, AE, BE, CE, and DE are all equal. So AE, BE, CE, and DE are all equal. Now we're going to take this rectangle and we're going to change it again. And this time, instead of having a rectangle, I'm going to make it kind of loppy-jawed again. But what I am going to do is I'm going to attempt to make my sides closer to the same length. Probably not going to be able to get it exact, but you can get the idea that these sides are now pretty close to the same length. So if these sides are the same length, there's some new things that are equal about this parallelogram. This parallelogram is now a rhombus where all the sides are equal. So the first thing I need to know that's equal is all the sides are equal. And I don't know what the sides add up to on this case. If I did have a perimeter, I would be able to know what they all add to, but all of my sides of this rectangle are going to be equal. So this side, 2, 3, 4, all of them are equal. Now, it is no longer true, however, that the diagonals are equal. You can actually look and tell that if I mark my two diagonals, this diagonal in red is clearly a little bit longer than this diagonal that I'm marking in pink. So my diagonals are no longer the same length because that is true for rectangles, but not for rhombuses or other parallelograms necessarily. So the other thing that is true if I have a rhombus, though, is that these diagonals that I have marked split those angles they touch in half. In other words, this angle is split in half, and this angle is split in half. Now, what that actually means is all four of those pink angles are equal. And the way I would describe this is that I would describe that as starting at angle B here. So, I'm sorry, at D here. If this is D and this is A, I'm sorry for my stylus, it's not wanting to work too well, but I have angle DAC, which is this angle right here, would have to be equal to angle BAC, which is this angle here. Furthermore, it also has to equal the other two angles that I originally marked in purple, these two angles here. Because if A and C were equal and I cut them both in half, all four pieces are equal. So DAC is equal, BAC is equal. Also, I have BCA. And then my final angle I have there is angle DCA. All of those angles are equal to each other. Now, we won't take the time to write it down, but if I went and looked at the other side, this and this would be equal, and this would be equal. So I'd have all four of these angles, 1, 2, 3, 4. Those four angles would all also be equal. So for a rhombus, I not only know the sides are equal, but I know when it divides it into the little things, they are equal. The other interesting thing I know about the rhombus is these angles in the middle are all equal. So if I call this point E again, I can say all the angles around E are equal. And since there's four of them, the other thing that's true is not only are they equal, but they are 90 degrees. So there are four 90-degree angles right there in the middle of that shape. Four 90-degree angles, meaning the two diagonals are perpendicular. So it is true that all those angles in the middle are equal. And I have that line A to C is perpendicular to line B to D because there are four right angles there in the middle for any rhombus. Okay, and I'm going to show you one more thing with all of these shapes. And what I want to show you is the square. And I know a lot of you think the square is a very easy shape to identify, but it's got a whole lot going on, because one thing that is true of a square is because since all the angles are equal, and they're all 90-degree angles, this is a rectangle. So it's true that this is a rectangle. And it's true that it's a rhombus, because if all the sides are equal, it's a rhombus. So since a square is both a rectangle and a rhombus, now a rectangle does not have to be a square, and a rhombus does not have to be a square, but if it is a square, it is both a rectangle and a rhombus. That means everything we went over that is true for a rectangle or for a rhombus is true for a square. So if I go to, I'm not going to write all of it down, but we'll mark it up very quickly. It's true that all the angles in the middle are equal. And so I have four right angles in the middle there. It's true that these diagonals bisect the angles in the corner. So I have these angles are equal. And then it turns out in a rectangle, the adjacent angles were equal. So these angles are also equal. It's not just the ones that are across from each other, but all 8 of those angles formed by the diagonals in the corner are equal. It's also true for a square, just like on a rectangle, you could say all the pieces of the diagonal are equal. That is also true for a square. So all of these are equal. And then, of course, the big angles are equal, and the sides on the outside are also equal. So pretty much in a square, anything you can think of that might be equal will be equal. The angles in the middle I've marked in blue as 90 degrees. The 4 diagonal segments, the 8 diagonal angles in the corner, the 4 sides on the outside, and the 4 big angles on the outside, all are equal. Pretty much anything you want to be equal in a square is. Hope this helps you distinguish between the different types of parallelograms, and please let me know if you have any questions.